11.4, solving equations and applications dealing with these logs. Example 1, we have solved log x plus 3 is equal to 2. In order to solve this, we want to get rid of the log, and in order to get rid of the log, we need the same base on both sides of the equation. So our base here is understood that it's 10, so if we rewrite this as 10 to the power of log 10 of x plus 3 is equal to 10 to the second power, this 10 cancels out the log, and we're working with x plus 3 is equal to 10 to the second power, which is 100. We're going to move the 3 over by subtracting it from each side, and we just get that x is 97. For example 2, we have log 2 of x plus 3 plus log 2 of x minus 3 is equal to 4. We know that log 2 of something plus log 2 of something is going to represent multiplication. So this is the same thing as saying log 2 of x plus 3 times x minus 3 is equal to 4. If you want to multiply these right now, you can. If not, you don't have to. You can realize that there's a base of 2 here, so you need the base to be 2 on both sides in order to cancel out the log. So we're going to have x plus 3 times x minus 3 is x squared minus 9 is equal to 2 to the 4th power, which is 16. We're going to move the 9 over by adding it to both sides, and we have that x squared is equal to 25. We take the square root of both sides, and we have that x is plus or minus 5. You have to check these. You cannot take the log of a negative number. So if you plug in the 5, you have 5 plus 3 that gives you 8. That works. You plug in the 5 for the other, you have 5 minus 3 gives you 2. That works. If you plug in the negative 5, you have negative 5 plus 3, which is negative 2. You cannot take the log of a negative, so the negative doesn't work for this, and x is only going to equal 5, positive 5. For example 3, we have log x plus log x minus 1 is equal to log 8x minus 12 minus log 2. So I want to simplify this on each side first. We have addition on the left side, so we're going to multiply x times x minus 1. So it's going to give us log x squared minus x. And on the right side, we have subtraction, so we're going to divide. So that's going to be log 8x minus 12 divided by 2, which we can rewrite as log x squared minus x is equal to log 4x minus 6. We have the same base on both sides, so these will cancel, and we're just going to work with the x squared minus x is equal to 4x minus 6. We're going to move the 4x over by subtracting it from both sides. I have x squared minus 5x is equal to negative 6. We add the 6 to both sides. We get x squared minus 5x is plus 6 is equal to 0. From here, we're going to find the factors of 6 that add up to be negative 5. They have to be the same sign, so we're going to have negative 2 and negative 3 give us negative 5. So this factors out to be x minus 2 times x minus 3 is equal to 0. We set each of these equal to 0, and we solve for both. We're going to move the 2 over by adding it to both sides. We also are going to move the 3 over by adding it to both sides. So this is going to give us x is equal to 2 and x is equal to 3. We need to check both of these though. So if we plug in the 2 for each of these 2, log 2 is fine. 2 minus 1 gives us 1, that's fine. 8 times 2 is 16 minus 12, that's fine, so that works. If we plug in a 3, same thing, that works also. So both of these are our answers. For example 4, we have 2 to the power of x is equal to 10. We're going to take the log of both sides here. So we have log 2 to the power of x is equal to log 10. From here, we are going to take the x that's on the exponent on that 2 and bring it to the front, so it's going to be x times log 2 is equal to log 10. We're going to divide each side by log 2 to get x by itself, and we're going to use our calculator, and we're just going to do log 10 divided by log 2. So log 10 divided by log 2 gives us 3.32192895, so on. We're going to round to 4 decimal places. This is going to be 3.3219. Example 5. We have 2 to the power of x squared is equal to 4 to the power of 3x minus 4. That 4 can turn into 2 to the power of something, so this is going to be rewritten as 2 to the power of x squared is equal to 2 squared to, 2 to the second power times 3x minus 4. Now that your bases are the same on both sides of that equal sign, cancel them out and just work with your exponents. So we're working with x squared is equal to 2 times 3x minus 4. Distribute the 2 in there. You have x squared is equal to 6x minus 8. Move your 6x over by subtracting it from each side. We have x squared minus 6x is equal to negative 8. Add your 8 to both sides. We have x squared minus 6x plus 8 is equal to 0. We want to find the factors of 8 that add up to be negative 6. So we have a negative 2 and a negative 4. So this factors out to be x minus 2 times x minus 4 is equal to 0. We set each of these equal to 0 and solve for both of them. We're going to add the 2 to both sides. We get that x is equal to 2. Add the 4 to both sides. We have that x is equal to 4. So you have 2 solutions for this one, the positive 2 and the positive 4. For example 6, we have 2 to the power of x minus 1 is equal to 3 to the power of x. We're going to take the log of both sides here, so it's going to be log 2 of x minus 1 is equal to log 3 to the power of x. We want to simplify these radicals, so it's going to be, these exponents. So we're going to bring them out front, so it's going to be x minus 1 times log 2 is equal to x log 3. We want to distribute that log 2 into both the x and the negative 1. So it's going to be x times log 2 minus log 2 is equal to x log 3. We want those x logs on the same side. So we're going to move this x log 2 over by subtracting it from each side. They are not like terms because the whole number there is not the same. So we're just going to rewrite this as negative log 2 is equal to x log 3 minus log 2. This should be x log 2. From here, we can factor out an x from that right side. So we have negative log 2 is equal to x times log 3 minus log 2. You remember that subtraction means division, so this is the same exact thing as saying negative log 2 is equal to x times log 3 halves. You want x by itself, so we're going to divide each side by log 3 halves. Use your calculator. You're going to do the negative log 2 divided by log 3 halves. This is going to give us a negative 1.7095. Yep, that was it. So if we look at our last example, it tells us to find log 7 of 99 to 4 decimal places. When we are doing these and we don't have an actual equation to solve for, we're just simplifying something, and we can't do 7 to the power of something is equal to 99, we're going to take the log of that big number, which is 99, over the log of the base, which is 7. So using your calculator, just do log 99 divided by log 7, round to 4 decimal places. This gives us 2.3614. So with ones like these, you're doing the log of your big number, the one that looks like a regular number, divided by the log of the small subscript number, which is your base.